Okay, sorry about that. I am back. So let me start again on number 5. So again, variables on both sides. So I see 2 times 6a gives me 12a, and 2 times negative 4 gives me negative 8. And look at what I see. The same exact thing is on both sides, same expression. So if I was going to continue to solve this and add 8 to both sides, these are going to cancel. I'm left with 12a equals 12a. 12a is positive, so I can subtract 12a from both sides, and I'm left with 0 equals 0. That would be an infinite solution. Why? Because the expression on both sides is exactly the same. It doesn't matter what number I substitute in here for a, I'm always going to get an equivalent answer. So, for example, if I substituted a equals 1, 12 times 1 minus 8 is always going to be the same as 12 times 1 minus 8. That's 4. I can do a 2. 12 times 2 minus 8 will always be the same as 12 times 2 minus 8. That's 24 minus 8. That's what, 16? Any number that I pick, fraction, decimal, positive, negative, whole number, even 0 is going to work. Infinite solutions. Okay, number 6. I have variables on both sides, but I don't have the same thing. So sorry, this isn't an infinite solution or anything like that. I do have 6x and 3x, both positives. So I can subtract 3x from both sides, canceling out the 3x here. 6x minus 3x is 3x. Since I have my variables together combined on the left, I'm going to get my constants combined on the right. So I have a minus 5, I'm going to add 5, inverses, subtraction and addition. That leaves me with 3x equals 18 when I combine up 13 plus 5. Dividing both sides by 3, x equals 6. So just like I was talking about solutions over in number 5, let's look at why 6 is a solution in number 6. So 6 times 6 minus 5 should be equivalent to 3 times 6 plus 13. See what I did there? Because x equals 6, where I had the x's in the problem, I'm substituting in a 6. So 6 times 6 is 36 minus 5, and 3 times 6 is 18 plus 13. 36 minus 5 is 31, and 18 plus 13 is also 31. So that's why 6 works. There isn't any other number that would make these two sides equal. Let's look at something that's not a solution. So let's say 1. 6 times 1 minus 5. 3 times 1 plus 13. 6 times 1 is 6, and 6 minus 5 is 1. 3 times 1 is 3, and 3 plus 13 is 16. That didn't work. That's why 1's not a solution and 6 is. Okay, moving on to number 7. I see a lot going on here. I have division, I have subtraction, I have multiplication. So I've got to move from the outside in. I want to get that the a alone. Let me erase this stuff so you can see a little bit better. So the first thing I'm going to do is I'm going to multiply by 3. 3 divided by 3 is going to be 1. I'm left with 4a minus 2 equals 18. Again, I'm moving from the outside in. I'm trying to get the a by itself. I like to think of the variable as like a little princess, and she's got all these bodyguards. We've got to be a little ninja and get rid of everything that's around this variable. So moving from the outside in, I'm going to add 2. 18 plus 2 is 20. I'm just going to rewrite it over here to finish it off. I'm multiplying by 4, so I've got to divide by 4. And 20 divided by 4 is 5. Let's check my answer just to be sure, since this was kind of a hard problem. Plugging it back in, 4 times 5 minus 2 divided by 3 equals 6. 4 times 5 is 20. 20 minus 2, 18. 18 divided by 3, 6. It works. Do you see what I see in number 8? Distributive property on both sides. Times 9 times 9. Times 3 times 3. 3 times 3x is 9x. 3 times 4 is 12. So I have something kind of similar to what I saw in number 5, but not the same. I don't have the same thing on both sides, but I have the same x on both sides, but not my constant. So let's see what happens. When I subtract 9x from both sides because it's positive, I'm left with 9 equals 12. Last time I checked, 9 did not equal 12. So this is a no solution. You could spend the rest of your life trying to find a number to plug into here that'll work, that'll make both sides equivalent to each other, and it's not going to work. There is no possible answer. Positive, negative, zero. Zero definitely doesn't work. No fractions, no decimals. Nothing is going to come in here that you'll get a number equals a number, and those will be the same number. Okay, number 9. Again, we got distributive property on the left. We've got to do that before we can subtract the 5. So 5x plus 15 minus 5 equals 15. So 5 times x was 5x. 5 times 3 is 15. I'm going to combine like terms first, and then I'll start doing my inverse operations. So my like terms are right here, 15 minus 5. Now I'm going to start my inverse operations. Subtract 10, subtract 10. That leaves me with 5x equals 5 from 15 minus 10. Divide by 5, x equals 1. Nice and easy to sub this in again and make sure that it works. Go to the original problem and put a 1 in. Now it's just an order of operations problem. Combine up your inside of your parentheses first. 1 plus 3 is 4. 5 times 4 is 20. Subtract the 5, 15. Just like we wanted. Proportions, there's a lot of different ways that we can go about this. A lot of you know butterfly or cross multiplication. So we know that the numerator of one of our fractions times the denominator of the other fraction has to equal the numerator of the other fraction times the denominator of the other fraction. So basically, 6 times 21 needs to equal 18 times W. 6 times 21 is 126. So to get our solution, we're going to divide by 18. And 126 divided by 18 is, I think it's 14. No, it's 7. I'm silly. So there's all kinds of patterns that we see in equivalent fractions. One thing that you can kind of see when you look at these two equivalent fractions is 6 times 3 is 18, just like 7 times 3 is 21. Sorry, I'll use a times. Good way to check it.